All right, I guess I left off on arc fault circuit breakers. It says the code requires that any 125 volt, 15, 20 amp branch circuit that is not GFI protected must be protected by an arc fault circuit interrupter, AFCI. The FCI opens the circuit when an arc fault is detected by detecting arc faults. Arc faults will help prevent fires, or AFCIs, will help prevent fires from starting. The breaker from an AFCI is similar in appearance to the GFCI. Okay, the arc fault detects arcing faults that are not detected by standard breakers or GFCIs. Typically, the condition may generate arc faults include. Okay, so what is an arc fault? Arc fault's an arc. So why doesn't the GFI pick it up? Well, if there's an arc between the hot and the neutral, guess what? That ampacity goes up on the hot and the neutral, and that's what the GFI is reading. And the only way a GFI would pick it up if it's a fault to ground. It may not be high enough, but if it's arcing enough to ground, and then there's a possibility that a GFI would pick it up. Okay? But when it's arcing between two hots or a hot and a neutral, the GFI will not pick it up because the GFI is going to be seeing the same amperage on both wires. So what causes it? Damaged wires. So if you got two wires and the insulation is broken up and or sliced a little bit, and they'll start arcing across. Frayed conductor insulation, loose electrical connections, overheated or otherwise stressed electrical cords. So you got a cord, you got too many things plugged in, and the insulation starts to fail. Damaged electrical appliances. Okay, so you got a range and it starts to arc across, or you got, Jonathan works in with stoves, and the insulation starts to melt off. Guess what? Those wires can start arcing across, and the arc fault breaker picks up because it's high currents. Anytime it makes that spark, that arc, that's high current, so that's what it's going to pick up. Equipment grounding. In addition to equipment grounding, metal enclosures and part that can be energized must also be grounded. This process is called the equipment ground. It is needed for the following reasons. The grounded conductor neutral or the circuit will at times carry an unbalanced load and will therefore become a current carrying conductor. Okay, so that's why we're never going to use that neutral for grounding something out. We're using a ground. We're grounding all the metals. Guess what? That neutral and that hot may be carrying current. By grounding equipment in conductive enclosure, the voltage to ground potential is limited. Equipment ground provides a current path during a fault condition so that overcurrent protection device operates properly. Okay, just remember is when you're trying to ground something out, you have to have a good solid ground, because if you don't, and the path goes to ground at where it's being plugged in, it doesn't get back to the fault, to the breaker. It doesn't turn the breaker off. Remember I was telling you about that run somebody did, 150-foot run with half-inch flex, and they pulled 3 hots and a neutral, no ground. I guess they decided to use the ground, the flex as a ground. Well, anytime you have flex more than 6 feet, you have to have a ground in it. Well, when there was a fault in it, and the breaker tripped. Okay, when I went and checked, I couldn't find what tripped it, so I went and turned the breaker back on. When I turned the breaker back on, 2 other breakers all of a sudden just made a and then boom, 3 breakers tripped. Now I'm like, whoa. By the time I brought my hand down, turned the breakers on, and I brought my hand down, and it started doing that noise. By the time I got my hand back up, say 2 or 3 seconds, boom. When I went back into the room, I opened up the J boxes, and here's 12 wire, well, not 12, about 10 wires in each one, 13 wires in each one, whatever it was. It was the 4 wires in, 4 wires out, and the 2 wires going down. So it's 10 wires in a box. All of them were bare. The insulation, you can look at the bottom of the box that the all the insulation had melted off. It got that hot in just a few seconds. Okay, why? Because they didn't have an effective grounding path back to the source to turn the breaker off. Stray currents, leakage, and static electricity can drain or ground, preventing injury to people and damage equipment. Okay, stray currents. So you don't want this current to stray and go somewhere else because of a frayed insulation and go and hurt someone. 2 sections of the code discuss enclosure grounding, 250-80 and 250-86. These sections require nearly all metal enclosures be effectively grounded. Part 7 of an article lists the grounding methods for specific equipment. Never ground equipment to the grounded neutral conductor on the load side of the service. Why? Because you're going to make that hot. There's a chance that neutral carry current, now it's grounded to a metal box. Now you can energize that metal box. Somebody unforeseen, unknowing, or whatever reaches up to turn the switch off, and those 2 little ground screws are hot now. Yeah, so you got to be careful of that. So it says, if equipment supplied by metallic raceway, metallic wireway method, it must be grounded. This applies to the following wire methods: metal conduit, including flex; metal tubing, including flex; metal raceways, wireways, underfloor ducts, bus ducts, armored cable, mineral insulated cable, metal with a metal sheathing, metal clad cable, and metal jacket cable. It says locations. If a person in contact with a grounded enclosure and the ungrounded energized enclosure simultaneously, a ground path through the person could occur. This could cause severe injury or death. The code contains requirements to prevent dangerous situations on all electrical equipment within 5 feet horizontally and 8 feet vertically of any grounded surface. Device must be grounded. This prevents 2 pieces of equipment having a potential difference. I talked about that when we're talking about in the last class, the difference of potential. You know, where I was saying, well, you don't want the desk at one potential and the chalkboard another potential. And if I'm touching both at the same time, and then because there's a different potential, I can get shocked by that difference of potential. If they're all, let's say, 3 volts, if I got 3 volts at the desk and I got 3 volts at the chalkboard, and then they're the same, so it's not going to cause anything. But if one is 0 and the other one's 3, well, I'm going to get hit by that 3 if I'm touching both at the same time. It says water increases the possibility of electrical shorts and faults. If it contacts a current carrying conductor, water can conduct the current to other items at which it is in contact, such as an equipment enclosure. So again, if you get something that's not grounded, it gets energized, and it's in water, whatever's close, whatever's touching that water becomes energized. Like that story about the guy that got shocked leaning up against my construction trailer that was energized, and Trent was relieve himself. It says the current flows through the person, therefore the electrical equipment installed in the damp wet location must be grounded. Any non-electric equipment that is in contact or likely to come in contact with electrical equipment requires grounding. It says some equipment enclosures do not require grounding, as in general rule, devices that are double insulated, guarded, isolated, or exempt from grounding. When entering junction boxes, equipment ground conductors should be connected to each other and bonded to the metal box. This maintains the continuity of a grounding system. So if you're running, you got 3 conduits that are entering a box, and each one has a ground wire, well, you have to put tie them all together. Put your pigtail to tie onto the box and get a pigtail to tie onto your device if a device is being installed in that box. Code alert. An effective ground fault current path. Article 250.4A5. Earth not considered an effective ground fault current path for electrical systems, grounding systems. Equipment grounding. Equipment grounding conductor size based on an overcurrent protection device using NEC 250-122. 250-122 is if I got a 15 amp breaker, I use a 14 gauge wire. If I have a 12 gauge or 20 amp breaker, I use a 12 gauge. If I got a 30 amp, I use a 10 gauge. From 30 amps to 60, I use a 10. Over 60 and under 100, I use a number 8. Over 100 to 200, I use a number 6. So the table here explains, and this gives you a simple problem. It says a piece of equipment is supplied to a circuit with 100 amps circuit breaker. What size equipment ground conductor is needed? According to 250-122, minimum size equipment ground conductor for grounding in raceways and equipment. So here's 100 amp. 100 amp is number 8. The 6. Oh, I'm sorry. Number 8 up to 200 is going to be 8, not the 6. I'm sorry. Okay. So once you get above 60, okay, use table 250-122 for 100 amp overcurrent protective device and 100 amp copper conductor or 6 aluminum copper gauge aluminum. Ungrounded systems. The ungrounded systems, a neutral conductor, not the ground. Section 250-21A. In an ungrounded system, the neutral conductor is not grounded. The equipment ground conductor, metal conduit, armored cable, BX is used to bond all metal enclosures carrying parts of electrical circuit to the ground electrical system. Section 250-21C of the code has more information regarding the ungrounded systems. Okay, so that's when your neutral is not grounded. Grounding electrode systems. Current travels back to the service equipment through the grounding electrode conductor, the grounding electrode, and dissipates into the soil. Okay. What are some of our systems? There are many types of grounding electrodes permitted by the code. Sometimes a portion of the construction can be used as a grounding electrode. So it says underground water pipes. And that's 250.52A1. It says an external water metal pipe that extends from at least 10 feet underground can be used as a grounding electrode. Any metering in the pipe must be bypassed with the bonded jumpers. So if the meter, let's say the meter of the house is up at the front and the meter is at the curve. Well, it's 30 feet away, 40 feet away. And then you're okay. You don't have to put a bonding jumper across because you already have, let's say that's metal pipe. That it's metal pipe. If it's PVC, and then it's useless. Okay, so if you got a house and they're using PVC as a main source for the water, you can't use it. Not permitted in grounding electrode. According to section 250.52B, aluminum electrodes, metal underground gas piping systems, and structures and structural reinforced steel as described in section 680.26B1 and section 680.26B2 shall not be used as a grounding electrode. Okay. Building steel. Building steel, the metal framing of a structure can be used as all or part of the grounding electrode system. In most instances, the building steel is connected to the 3 driven ground rods placed near the building in a triangle pattern. The ground rod grouping often. Okay, and this is Article 250.52A2. And referred to as a triad in case ground integrity. So somebody will go in there and they'll stick 3 ground rods in a little triangle and then they tie them all together. Concrete encased rebar. Concrete reinforced bars that are ½ inch in diameter, number 4 or larger, and at least 20 feet long can be used as a ground electrode. No other supplement electrodes are needed. A 4 or American wire gauge copper or conductor at least 20 feet long embedded in concrete is also an acceptable grounding electrode. So you can just get a piece of wire, 20 feet of number 4 wires, solid, bare, and put it in. This is 250, Article 250, 52, A31, and 250, 52, A32. A ground ring. A 20-foot or greater length of bare 2 copper, buried 30 inches below grade and encircling the structure, is frequently used as a grounding electrode. So this is your, like a U for ground. If none of these electrodes are available, the following systems can be used. You can use buried tanks, like you got not a gas pump, but you got water tanks underneath, or something that's metal underneath a tank. You can use them as grounding. Metal plates consisting of at least 2 foot square of exposed area buried at least 2.30 inches below grade can serve as a grounding electrode. Ground rod, a driven ground rod at least 8 feet long, placed vertically or at an angle not greater than 45 degrees, can serve as a grounding electrode in areas where subsurface rock prevents. Driven the ground rod, it can be buried horizontally at 30 inches. So we just did in one area when the utility would come in and they dig in their ground, their wire, the service, their laterals, and we would go back. It was all rock. They had a big grinder. They grind this trench up to get in the trencher. It was a big wheel about 12 feet diameter. And once they got it all trenched up, as soon as they had it, they'd leave it up. We go in there and drop a ground rod, put a wire up. And then they drop the wire and they cover the hole. You know, every time we saw them, we went out there and dropped our ground rods in. Because if we're using the underground water pipe, the building steel, or the concrete encased rebar, or even dropping the rebar inside the concrete, inside the slab, they're still going to require you a supplemental. So your ground rod now turns into a supplemental. These are my main groundings, but my ground rod is a supplemental ground rod. Okay. When I'm using this, I'm using a number 4 and up. Okay. If I'm going to my supplemental ground rod, all I need is a number 6 wire. I don't need anything bigger than that for the supplemental. Okay. Some inspectors may tell you otherwise because they see the ground rod. Oh, it's got to be number 4. Oh, it's got to be this. Or it's got to be that. No. Okay. Not permitted ground rods. I read that. Ground electrode systems, made electrodes. Those are your buried tanks, metal tanks, ground rod. Must be a conductor connecting electrode to the ground bus. So if you're using any of these, you got to have a wire that comes up. How do you size the grounding electrode to the bus bar? Well, you go to table 250-66, and there is exceptions A through C. Okay, so here's your tables. So, for most parts, 100 amp, 150 amps, 200 amps. So your wire, this is your wire right here. Whatever wire you're using going up, is what you got to have. It's 2/0 or 3/0. Okay, so that's your 200 amp, residential only. Well, you can use a 3/0 for commercial. If you're doing residential, always remember, for residential, you can use 2/0 for a 200 amp service. You're doing commercial, you have to use a 3/0. Sample. The service is fed from a 250 kc mil copper THW conductor. What is the maximum size grounding electrode? So they're using 250 copper kc mils. So there's my, that's aluminum. This is copper. Shouldn't say over. That should say, oh, it says over 3 aught. I'm sorry. Over 3 aught to 350. Okay. Well, the 250 is larger than a 3 aught. Number 2 wire. Again, there's a table. So we had a 250 over 3 aught through 350. Down here is 350 and above. That'd be the number 2. Accessible connections. Section of the grounding electroconductors or bonding jumper to the grounding electric shall be accessible. So wherever you make that connection, it has to be accessible. Grounding methods. Grounding conductor correctly connected to the and size. So your grounding conductors have to be sized according to either, if it's a equipment ground, 250 122. If it's a grounding electrode conductor, yeah, 250 66. NEC article 250. Panel boards, grounding methods. Okay, all our grounds are in article 250. Panel boards, basic arrangement for grounding distribution panels as follows in figure 11.6. Here's 11.6. Let me see if I got a picture up on top. There it is up on top. So again, if this is a sub panel, not the main panel, this is a panel board somewhere else away from the sub panel, from the main panel. Okay, because at the main panel, that's where we have our grounding and our neutral bonded to each other. That's when we're grounding is neutral wire. Now we're at a separate panel board, and then down the hallway up on the 3rd floor, 4th floor, whatever it may be. Our ground goes to the ground bar, our neutral goes to the neutral bar. Okay. This ground is sized according to these wires and the ampacity of these wires. So let's say this is a 200 amp and it's got 4 aught. They ran 4 aughts to it. Okay. So we come over here, 200 amps, number 6. When grounding panel boards follow these guidelines, install an approved grounding bar. The grounding bar is securely fastened to the inside of the enclosure and the cabinet. Right there, there's bonded. Never connect neutral bar to the grounding bar. This is only permitted at the service. Again, it's only permitted at the service. You can only connect these at the service. This is the ground coming in, and we're bonding to that panel. A lot of times this may be already screwed onto the metal frame, and then you don't have to have that bonding jumper because the screws going down is enough. Okay. This would be isolated from the metal frame. Bonding neutral, section 250.24c. Several neutral conductors from the grounded power supply terminates at each service disconnect, mean via a main bonding jumper installed between the service neutral conductor and each service and disconnect means. So if you got 6 meters coming in, guess what? They all got to be bonded together. Cord and plug devices. Cord where the metal covering connects equipment or equipment to the plug prong. Okay, so again, if you got a piece of equipment and say it's cord and plug connected, you have to have that ground touching to that metal frame. The grounding has to be a 3-wire. Your hot neutral in the ground, or 2 hots in the ground, or a 4-wire where you have 2 hots neutral in the ground. Conductors where the cord connects the equipment and ground plug prongs. So always have to make sure that it's connected to both sides and you have continuity between both. Separate external and flexible. So separate external flexible conductor can be run from the equipment case to the grounding electrode. So maybe you want to run a separate ground wire instead of your equipment ground, where you have a more solid. Say your wires coming in are number 6s, but they want the equipment is requiring a number 4, and then you can run a separate wire externally. That's what it's talking about. Permanently